Okay, so let's have a look at some examples of transverse waves. Most of the waves we are going to meet together across this course are transverse waves. So if you're never sure what type of wave is, I would just guess it's transverse. Here's a bunch of examples. The entire electromagnetic spectrum of waves, we're going to meet all of these: visible light, microwaves, infrared, radio, X-ray, gamma rays, you name it, ultraviolet. Yeah, these are all electromagnetic waves, all transverse. Water waves also can move in a transverse wave. You might have seen that in water. For longitudinal, let's just stick to two things for now. Sound waves is traveling as a longitudinal wave to reach you, and also some types of pressure and shock waves. Yeah, they're the longitudinal waves I want us to have in our brains at the moment. Okay, so right here, I have a diagram that we're going to draw, and we're going to actually use it to label different types of things on a transverse wave. It's really important we can pick out key features on a transverse wave. So we see we've got our y-axis here and our x-axis there acting as a rest line or a zero line. Yeah, we see we've got our transverse wave going up to the top and then down again and then up again, crossing and transversing, crossing over that zero line in the middle. Right? How tall our wave is from that zero line. So what's marked A on this diagram here is known as our amplitude. You might recognize amplitude from amplifiers. Amplifiers for guitars or other instruments, they make things louder. So if you increase the amplitude, you're increasing the loudness of the wave. If this was a digital sound signal to later turn into a longitudinal wave and be transmitted across. B there is showing us the wavelength, how long the wave is, right? Just how long a wave is, it's in the name, okay? Misconceptions people get here is they draw the amplitude from the top all the way at the bottom. No. It's just from the top or the bottom to the rest line. Misconceptions people do with the wavelength is they draw it too long or too short. My wavelength there is showing one point to the other point before the wave starts again. Wavelength. We're going to measure both of these in meters because both of those are lengths, the heights. The amplitude's measured in meters, the wavelength's measured in meters. Okay, there's our amplitude, there's our wavelength. Two more terms we're going to introduce here. The crest, like the crest or the peak of a mountain, we can call D the crest or the peak of the wave. And then C, we can call that a trough because it's kind of like a trough that pigs eat out of. Yeah, the little trough that they eat out of. So A is the amplitude in meters. Wavelength is B, also in meters. The top's known as the peak or the crest, and which is D on there, and curly cut C is our trough, the top, the bottom, that our pigs are eating out of. Wonderful. And here's some definitions for me to help you memorize. Wavelength, distance from the peak to peak, or the trough to trough of a wave, or two different points of a wave. Or amplitude, the height of the wave above that zero or rest line. And then here's another thing that you can't actually mark on a diagram like this, but you could add on as an extra fact. The frequency is how many waves are passing every single second. That's measured in hertz. So you could have something with a really low frequency, not many waves passing per second. Or we could have one with a high one, loads of waves passing every single second. High frequency. Frequency is how often something happens. The metros are coming very quickly. High frequency. Takes a long time for a metro to show up. Low frequency. Okie doke. So last task I want you to do while I'm talking with you today, before you follow the extra tasks I've added on, I have these definitions here. I would like you to match those up for me. Match the correct term to the correct definition. Pause this now, then we'll go through the answers, all right? So, waves transfer from one end to the other place without the need for particles. Wavelength, distance from peak to peak. Frequency, number of waves per second. Amplitude, boom. Height of the wave above the zero line. Give yourself a thumbs up, give yourself some ticks if you got that right.